Hello guys, my name is Arun Tyagi, and today I'm going to talk about system design of systems like social network like Facebook and Twitter, where people post and people read post, people add friends, and people follow some celebrities and famous users, you can call them. To start with, let's start with the functional requirement or what all functionalities this system should provide. So I'll mainly cover the main functionalities, and obviously we cannot cover all aspects of it. So one of the main functional requirement should be is like where user should be able to post their stories, or their post, they call it. So in that, they can be, obviously there will be text, there can be images, which is obviously very famous, and then finally they should be able to upload videos, and also they can post links and all. So we'll cover this. Then user obviously should be able to see their timeline, and there they should be able to see, you can say, content from their friends or people whom they are following. Then they should be able to see content from famous celebs, and also you can say content of a particular category, right? Sometime you see, you get posts from which are of content, maybe you are not following those people or you are not friends with those people, but still you will see that content. Then so these are two main things. Then obviously you should be able to do like any post, you should be able to comment on any post, you should be able to comment on a comment itself, recursively, or you can say a tree structure will be built there. Then you should also be able to share, reshare these tweets or post. Then another thing is, you can say, things like you should be able to add friend or follow people, add friend or follow, right? So these are the main functional requirement which we will try to cover. Other than this, I think, yeah, if system like this, what is the most important aspect of these systems is doing user profiling, right? Where you are systems are trying to create a profile of the user, that what kind of a content, what kind of advertisement we can show to this user, or what kind of a content this user likes, so that they can feed the right content for the user, relevant content, and also you can push those advertisement for that user. So user profiling, again, will try to touch on that aspect also. Now when we talk about non-functional requirement, and also you can call it user experience, what kind of experience you want to give to your user. So in that, first is this will be a read heavy, it is like people are continuously scrolling, continuously, very frequently they're coming onto the system. So you can say this is a read heavy, and but people don't want to wait, right, for your screen to render. So you can say very fast data load, and I'm not talking about rendering on the UI, I'm just talking about backend system should be able to send the data very fast. Then like I said, you are doing user profiling, so you should be able to send relevant data. So relevancy is another requirement of this. So you can call it like relevant data slash advertisement. And then we are talking about that in terms of user experience, you can also say that it's okay if you send something a little later. By that mean, if one of my friend posted something on tweeted something on Twitter right now, it's okay if I'll or a celeb posted something on Twitter right now, it's okay if I'll get it maybe 2 hours later, right? But first point was that when you are when you are requesting for your timeline, that data load should be very fast. But if somebody just posted something, it's okay if you will get it a little later. So in that terms, lag is fine, right? No need to show that data real time to all the relevant users, right? So these are the things which we will try to cover. Okay, now let's jump into the design. Let's try to design this one. So let's call it HLD for Facebook slash Twitter. So this is the design for how a user will create a post, how that post from your device, your browser, or from your mobile device, how user will basically post this into the system. So let's okay, let me just first introduce to all the services I have used here, and then I will talk about how the data will flow from your device to the system. So these are obviously client, and then you will have a load balancer, right? Then you will have something like a post creation service, which is responsible for taking all the requests from your client and then sending it to other internal services. So this is your web front facing service. Then in general, the data will be have to persist somewhere, so we are persisting it into this database. And here I'm taking Cassandra again. Why Cassandra? Because post is something like, again, ever growing data, and this will be a very huge data, right? And your queries will be to query something in this big of data is this is where Cassandra, or you can say column and RDB, performs very well, because your queries are simple. Give something for these user or this user, right? These kind of query, this kind of DB will perform very good. SQL will not be able to perform here, right? Then I will have things like an asset or a content upload service. This will be very similar to how I will design something like YouTube or content upload system. So I'll prepare a separate video on it, but think of it, it is going to handle all your video upload, image upload kind of thing. Then to support this, we have to have CDN, content delivery network, which is basically, though asset service is responsible to upload things here, but ultimately user, your end client, will be able to download from CDN directly, right? And then obviously when you are uploading the file, the you can say source of truth for all the files, that you will keep somewhere in a blob. So you already have blob services from all major cloud providers, for example S3 from your Amazon, and then from Azure blob from your Microsoft, right? So all the services are there that we can use. Then finally, I'll use a Kafka cluster to how these notifications will flow into the system, how this data will go from here to next services. So Kafka is being used for that, and obviously there will be multiple topics for different things. We'll talk about those topics. There's a Kafka cluster. Then basically think of a tagging service. This is responsible for if I uploaded something, be it a video, an image, or a text. So what this guy will do is this will try to categorize it. This will try to add some kind of tags on it, that this is related to educational field, or this is related to entertainment, right? Or this is something you can say abusive, right? Which you should not show to maybe who are not interested in that, or different kind of tagging. So a learning model is definitely required there to do that kind of tagging. Finally, I think this machine learning model should pump the same post back to Kafka, from which this post processing service will take it. What post processing service is responsible for is generating a cache for the user, right? That these are your data from where you can read it, right? And my user profile service is like from where you will get user detail. You will get details of how many direct direct friends, or two level friends, or friends of friend kind of a thing query you can do, because I merged a user profile plus user graph service. Graph service is for get my friends, get my friend of friends, get my who all celebrities I am following, those kind of things, right? So that will be used for this. Now how the data will flow. So it is very simple, that you are doing a post from your device, then it is going via load balancer. It will go to one of the post creation service server, right? And obviously this is kind of scalable, horizontally scalable, so there will always be multiple instances of it, be it in different region, or different areas, plus in same area multiple instances based on the load we are handling in that particular area. So that data will land there. Now if this is a simple text, it will simply sit into my DB first, where I'm persisting the data, and then event, basically we will send an event to Kafka, so that whoever is reader of those topics, they should read it and do rest of the work. If this is a video or an image, basically what will happen is this will go to asset service. Asset service will do things like, let's suppose you are uploading a video. You are uploading a very large video, large in the size, large in the terms of the size, right? You are uploading a 1080 into 1200 pixels, for example. But that kind of content is irrelevant when somebody is trying to fetch that data on small devices, mobile, or maybe somebody in poor internet. There you cannot serve that data. If you will serve that data, then their user experience will be very bad. Loading itself will take a lot of bandwidth, and that data may never load, right? So that is where this content service will come in picture. And what this guy will do is, it will do image and video processing on it. It will create multiple, you can say, copies of it, which can fit different best fit for different bandwidths, best fit for different pixel size requirement, and all those things. So that kind of work this guy will do. Obviously this will be a big design in itself, and we will discuss that in detail somewhere else. Then it will pump that data into CDN, basically. So and CDN again will be a huge network, and this is a solved problem, so we can leverage on it. So this will be like, you can feed the data directly into some region CDN, like for India, maybe for South India or North India, we are feeding into it rather than uploading it directly to the global CDN, because maybe master CDN don't even need to have those local videos, right? So we can optimize multiple things there, but this is how data will flow. Now once data will land into Kafka, your metadata including your tags and all, and from video service also, that metadata can go there. This machine learning model, it will basically tag it, add some tag, and pump the data back to your Kafka, and the data will come to your post for post processing. Now there are two kind of things. One is like, let's suppose I am posting something. Maybe I'm only having 20 friends, right? Or I'm having 20 people who are following me on social network. In that case, what this post processing service will do, it will fetch all my you can say relevant user to whom I should show this content. And if that number is less, what it will do is for all those 20 users, it will create different timeline, like for user X, user Y, user Z. It will append this post into their timeline here, and there will be things like timeline at time t1 is this, right? Things like that. So it will be done here. But in case of, let's suppose Virat Kohli is posting something, or a big celebrity who is having big number of followers, a very big number. In that case, we will not be able to do a write on Redis, right? Or any kind of data persistent for that matter, because if you are, even if you are having only 1 million follower, right, then also writing doing 1 million writes into a cache is a big task. And if you will start doing it, then basically it will stop performing for your read, whoever is reading from it, right? Because it will be busy in writing itself. So for those kind of users, we will not follow this model, right? We will talk about how somebody will read data from the celebs whom we are following. So this is about the simple user. When a simple user is basically creating a content, how it will be created. In case of celeb, what we will do is, if a celeb is posting something, it will flow to post creation service, and then ultimately these things are common, right? This will happen for every user, and ultimately it will sit into your Cassandra, and that's it, right? We will not do any further thing on it. Now let's talk about how somebody will read this data, right? So I'll create these guys here again. Okay, so let's check the scenario that how a user will basically read the how they will get the thing. And this is because my system is a read heavy system that we thought in starting, and obviously we can say there will be a 20-80 rule, that 20% of the users will be creators and 80% of the users are going to consume it. That means your read hit is going to be very high at any given point of time, right? So that is why what we did is we made our write a complex system where write is taking time doing so many things, but our read we are keeping it very simple because we want it like that. We are going fetching the data and just rendering. We don't have to do so many things, right? And that but give it but to some of the things we cannot do very simple. That is where we will have multiple things. So okay, let me talk about it. So again, user will hit beat your things like be it your device, your browser or mobile. They will hit a query like give me my timeline, right? And I'm not covering the scenario where you are trying to render the timeline of like we do on LinkedIn, right? We check all their profile, how many posts they did and all, because that's a very simple query. You can directly go into DB and get all the activities of that user. That is easy thing. I'm only talking about the main scenario where we have challenges. So user will do a simple requirement that give me the timeline where we are expecting we will get data from my direct or friend where in the friends where I am interested to read data from them. Then it should be able to give me the data from the celebs I follow, and that too relevant data, right? And finally mix of some data which is I am interested in. For example, if I am interested in space and maybe I'm not following Elon Musk, for example, or some other user I don't even know, and he is creating very good content. What if these platforms start posting those kind of thing on your timeline, right? Basis on the relevancy of the data and my interest, the reader's interest, right? So that is what I'm expecting, right? Now what I will have is a timeline service whose first responsibility is taking that request and then giving the data back to me. Now I will have something like a a celeb service. Like I said earlier, that for a celeb, when they are creating the data, we are just doing all the things, and the data is kind of stored into Cassandra, and we are not doing anything else, right? So celebrity service is basically responsible for when I'm sending, you can say I will give a list of celebs for whom I want the data, C1, C2 kind of a thing. That is the responsibility of timeline service, to give a relevant query, not like give celebrity data for this particular user. Then the celebrity service needs to talk to graph service and all, right? So timeline service will ease the thing for the celebrity service and simply ask for give me the latest data or data after this particular timestamp if anything got created for these given celebs. This guy will do a simple thing, though here also if number of celeb itself and content created by celebs are way too high, then we can have another cache here, right? If not, then what we will do is we will do a simple Cassandra query that give me data for these particular guys and after this time. So this guy will have the data and it will return that data back to your timeline service. Now timeline service needs to do two things. Even to query this C1, C2, C3 to your celeb service, what this guy will do is, first this guy will query your user service, your user graph service, you can say, that give me the list of all celebs and relevant celebs in which this user U1, whoever is requesting, can be interested in the the data for to read. So this guy will do whatever read on the graph, or ultimately SQL, nothing else. It will do the, it will run the query, it will return the list of celebrities, right? And that data will come back, and it will query to the celebrity service. In parallel, it will query the data. Okay, so this is first thing. Then in parallel, yes, it will query the data that give me whatever is, timeline got updated via this service for u1, and that data is already there. So you will query it, and ultimately you will do, merging, sorting of however you want to send it to the user. Plus you will do a write into this redis back, right? So why is that? So basically, let's suppose you are querying again and again. So you don't want to hit the celeb service again and again to get the same data. So if you queried something 5 seconds back, or 10 seconds back, or 1 minute back for that matter, right? You can serve that data from Redis directly. You don't need to hit this and this guy again and again. So to optimize these calls, we will write the data back to Redis, serve the data back to user, and if user is querying again and again, you will be able to serve it from here itself. And then the TTL means after how much time you should hit these services, that is again depends on how we want to serve, and nitty-gritty and low level details of it. What is my content creation pattern and content read pattern and all those things. So yeah, I think read is pretty simple here. My write was little bit complicated, but that is intentional so that my read is very fast. So this way I'm able to handle both, that if a user who is having millions of users, when he is creating the data, how that data should be created and served very fast. Also, if a user is creating the data who is having less number of users, how we can serve that kind of data also, given the fact that obviously my read is going to be very, very, very high, right? Hundreds of millions of requests are coming in every minute, kind of a thing, right? So yeah, that's it about this one. Let's jump to the next thing, which is basically, now we will talk about that. So one thing which I didn't talk about, and I think, okay, let me just talk about scenario like user profiling. So by user profiling, what I mean is basically we are talking about user profiling and user behavior mapping. So by this I mean is, if you see all these services, their major you can say revenue model is to show relevant advertisement, relevant content to the users. For that, we need to know our reader, right? What kind of data this reader is interested in. For that, we continuously have to improve our data, that we should send this kind of data to this guy, and this is their reading pattern, and these days the reading pattern is kind of changing. So let's try to design this, though it should be a simple one, but so yeah, so like I said, that how we will do user behavior mapping, how we will generate that data so that we can show them the relevant content plus relevant ads, right? Basically, we have users, we are recording the user's data, what kind of user, what kind of reader that particular user is, what they like, what they don't like, and all those things. So how this will be, like, user is basically, when user is live, user will be connected to WebSocket server. And how that will happen is, WebSocket server, actually I will talk about this in I already talked about it in WhatsApp kind of design, how WebSocket server, how you create connection and all those things. But I'll try to create basically real-time project also on it. That's how you can do that. Anyways, so let's suppose the user is connected, and what user is doing is basically they are scrolling. Some things they are reading, some things they are just reading and ignoring. And also you have things like where explicitly user is telling that I don't want this kind of content. And sometimes when when user is doing like and comment on some kind of content, right, though they are explicit things which user is telling you that I like this, right, I like this kind of content, I like basically interacting with this kind of content. But some of the things are implicit where user is not telling. What they are doing is they are basically spending time on it, and spending time means they are interested in that, right? And some things is they continuously ignore. So that is an implicit flag for you, for your system, that user is do not like this kind of content, right? So when user is doing that, when it is spending that time, you can continuously feed that data to, as you are connected to server, you can feed that data to your system back, though this is going to be very huge. So obviously this have to be scalable, and this depends now what kind of you can say um, business, RPI, return of basically this particular system, what kind of return I will get. If my return is very huge, then I will implement something like this. If not, then I will not implement. But let's suppose I'm going to implement it, then I will have this server, and obviously these are like scalable services, so there are always multiple systems, and any time you can increase the number of count, right, anywhere. So all of these individual items, like other designs also, these are individually you can scale them. So that data is continuously coming here. What you will do is you will feed that data into a PubSub model, right, where somebody will read it, right? So you are just simply feeding it, and that's it. You are freeing your client that okay, this data is done, and send me something back later. Then what you can do is basically you will have a user profiling service. Again, there have to be an ML model, right, which will do different work that based on where exactly they spend time, what they like, this that kind of a thing, a machine learning model will create, and then we will feed that data into our DB. So here it is okay to have SQL DB because this is like for this user, this kind of data. But again, if this data will be very big, for every user, if you will continuously adding it, here I am assuming that you will not continuously add. You will update the same entries for user. So one user is having, you can say max 50-60 lines where you are updating the data, right? That depends on what kind of model DB model will create. We are not doing continuous entry. We are just basically consuming the data, consolidating the data, and then storing it into my persistent layer, basically my persistence, which is my database. So that is why SQL will perform good here, good enough basically for this requirement. Once you have that data, then basically you are free to use it however you want. One of the example is my ads service. Whenever I'm having my ads source, and that I depends on from where you're getting, maybe that can be an external system or maybe some DB basically where all your ads are. Then on basis of user profiling, and you will get user detail from your user service, right? You will feed those data into, you can say, ads cache, right? And from here, when somebody is requesting for timeline, you should be able to feed these ads into the timeline for that particular user, right? And same thing you can use for relevant data. If you have to create relevancy, that service also will leverage on this data so that they can feed on your timeline data in the Redis. That user is already only interested in this kind of data. So this is how you can create user behavior, behavioral data, and also you can say user profiling, that what kind of user this is, right? So you can create a category of user, all those things on this basis. So this is again a simple thing. Now let's jump into our last thing, which is like how somebody will comment, how somebody will like, at particular post, how we gonna design it. Right. So let's suppose basically what I'm talking about is likes and comment. TSI design. So I will have. So finally, let's talk about how likes and comments we can design, right? So this area is same, right? So you can have, though I created separate comments and like service, obviously, because I'm expecting these are going to be, huge one, and so you should be able to scale them independently and individually. But obviously, when you are starting, you will have them into the same bucket in same service. Let's talk about the comments first. You will get comments. What you will do is, first you will persist them, and comments is again, what we are not talking about the DB structure. For something like comments, the DB structure, how you are storing that data set is going to be a little bit complex, because if you think of that, will become a tree structure, where comment parent will be a post, comment parent can be a comment, right? And there will be a hierarchy, so how you will load also, and it depends on what kind of user experience you are giving, on UI, whether it is like your first you are loading all the comments or the comments at till you can say the second level, right, in your tree. So for a particular post, do a graph query to get basically 2 level comments first, and then ultimately you will do the you can say aggregation and basically how sorting and everything here, and then ultimately you will serve. But having said that, what you can do is, because something like comments is again it's a growing data, right? If you see somebody, if a very celebrity posted something, then there are chances like you are continuously getting that kind of data, and you continuously have to serve also. So that is where you can keep it into Cassandra, first thing, because this is a growing data, and same way you can actually feed it into your Kafka. Now what we will do with those events, so whenever we are feeding into Kafka, is basically we are sending the events, and multiple services will use those events to do multiple things. We'll talk about those. So that is writing a comment. Doing a like is basically again multiple things. When you do like, you will first obviously save it into DB, that like by this user on that particular post, right? So you will have for post ID, user one did a like, that's it, right? Things like that. But what you have to do is you have to show those numbers, right? That XYZ plus 1000 users liked it, or that number can be keep growing very fast. So for that you can have a cache, and cache is not for all posts, but it is like when a post is active, right? So we cannot say new post because sometimes like when for example in India, when elections are coming up, suddenly people started commenting or liking some kind of things which they want to highlight, right? To do different things. So whenever a post is like inactive, we for that particular thing will keep the things into Redis, and we will do all kind of counters and whatever we want to do, that it is increasing. How you will handle the counter, that is again a different game, how you will manage, because you can continuously, you cannot do +1 into it. You have to aggregate it somewhere and then dump into your cache. So that is what you will keep it into cache, and you will be able to serve it very fast, because when somebody will require that particular post, The data serve you will be able to do very fast. Plus you will obviously feed this like also into your Kafka. Now when these things are going into Kafka, one of the thing which is happening is, like I said, it an explicit measure that that person is interested in this kind of content, right? So that way you will be able to serve this data for user profiling and categorization of user. And there can be other things like you can send it to notification service, right? So notification service will handle and send the notification those to users and all those things. For notification service, I already talked about that design in one of my previous video. So this is again a bigger problem to solve. So that exact design can fit here also. So think of it as a service out of the box available to you. You can use it. So likewise, it can be fed into multiple services and they will use this event. But overall, yeah, it will be this simple where these two can be one service. You are sending the data and then they are doing basically writing the data into ever growing kind of DB, which is a columnar Cassandra in this instant. And then ultimately to serve it, basically what it will do is, if you're serving on basis of the time that give me top this for this particular post, and then when you are fetching, you will basically fetch two level kind of data from the DB. Then you will do sorting, merging, creating that kind of thing using your adapters and send the data back to customer to your client. Same way for like, you will simply, if this is an active post, you will simply get it from your Redis and serve it. If this is not an active post and somebody is reading it, then from basically DB you can query that. That in DB also you can have two kind of thing. One is you will have multiple rows, right? And one is you can have a summary, that ultimately my summary is this, and at this it's the same summary which you are storing into Redis also, right? That basically you can say 1200 kind of people liked it, and these are the IDs of the user, right? So it depends on how you serve it. You can store the data that way. So I think, yeah, these are the three things which we should have discussed about it: how you post, how you read, how you do user profiling and all, and how they like and this thing, how they like and comment. What I did not talk about here is basically how you will create, how user will be onboarded, how user adding friends and following. That I'm assuming after discussing this thing will be a simpler problem to solve. So you can try yourself designing it, and you can post that design and we can discuss on that also. So I think, yeah, thank you very much for this one, guys, and yeah, take care. Bye bye. See you in the next design discussion. Bye.